our first speaker, Sau Sheong, and he, oh, sorry, forgot to unshare this, and he will be giving our first talk. Feel free to. So he works at SP Digital. He's from Singapore, and he has been working in software development for 25 years. He's active in both the Ruby and Go communities, and he has 4 programming books. The latest is called Go Web Programming, and it's published by Manning, in case you want to get it afterwards. Okay, I'll be signing off here.
Thanks, Vola. Am I on? Sorry.
Yes.
Okay. Hi, everyone. My name is Sau Sheong, and I'm not from Berlin. So I'm dialing in from Singapore, and it's about 3:15, 3:18 now here in Singapore. So it's been like half a work day for me. So today I'll be talking about IoT devices, right? So I work for this company called SP Digital, and I just want to talk about some of the work we have done there and how we use Go in our software. I also run the GopherCon Singapore conference. So unfortunately, we had to cancel it for this year. It normally runs in May. This is supposed to be the 4th year we are running this. Unfortunately, we have to cancel it because of the same reason why we are doing this online conference. But come next year, we'll be back, and hope to see many of you there. So let me start. I call this Controlling Distributed Energy Resources with Edge Computing and Go. So let me give a bit of a, okay, give me a sec. Okay, not sure why this is not moving. Okay, now it's moving too fast. No. Sorry about that. Okay, sorry, some technical issues there. So let me just give you some background on the energy industry first. So the energy industry, or rather the power and utilities industry, it's a conservative industry. Yeah, it's been around for 100+ years or so. And the industry is actually quite linear and quite straightforward for most of its duration, right? So it comes from generation to transmission, distribution, and finally to retail. So that's quite a linear path. But things are really changing, and things are changing because of many things. The ones that you really hear about are things on renewable energy, energy storage. There are a lot of things as a result of these technologies that they are regulatory changes, and of course of technology advances. When I talk about technology advances, it's not just merely the digital technologies that we are all probably very used to, but a lot of technologies that involve renewable energy and different types of energy sources and so on and so forth. So there is a parallel track, or rather a lot of advancement in that area. And if I do travel to Germany quite a bit, and because of my job, and that's because Germany is one of the more advanced countries in terms of energy use, and there's a lot of learnings and interchange between the utility companies. In fact, if you look at the first slide that I have, that it was taken by me when I was in Germany a couple of years ago, and just wanted to show that to talk about the industry. Okay, the slides are a bit slow. I'm sorry about that. So the industry is changing, and one of the things that we in Singapore has done as the utility in Singapore, SP Group, where the company I work for is the main utility group in Singapore. We started on this journey to do digital transformation about 4 years ago. In fact, exactly 4 years ago. And during this time, we tried a lot of different things to do optimization and to build out new technologies and so on and so forth, and to really understand what is happening around us, and try to use some of the newer technologies to advance ourselves. In the past 2 years, what happened was that after about 2 years of doing a lot of this work, we moved on to not just helping ourselves, but to start up a new company called SP Digital. And that's the company that I lead today. And we build technologies not only for ourselves, but also for our customers. Let's move on to the next slide. Again, it was working perfectly until we started the conference. So a little bit about SP Group. We are the main utility in Singapore. And most of our focus is on ensuring reliability in Singapore for the energy supply, electricity, as well as gas. I don't want to go back to the previous slide because it would take a bit back and forth. And our focus for SP Digital is on sustainability. So that is our main drive. We want to use what we call energy tech, technology used in the energy industry to drive changes leading towards sustainability. Okay, so what do we mean by that? Some of the things that we do in terms of the energy tech products, we create products for the country. We are the national utility. There is a certain level of obligation to deliver things for the country, and that drives a lot of the activities that we do as well. For consumers, now consumers are traditionally not a base for a base for utilities. Utilities, to be very frank, usually don't care too much about consumers, but that world is changing, and we are trying to get a lot more into this. So consumers then become one of the big focuses for us in SP Digital, and also for businesses who require energy and who require ways of using energy. I'll talk a little bit about some of these things. Now, the list of things that we do here are not exhaustive because I deliberately leave out a lot. Otherwise, I wouldn't actually have time to talk about the tech behind it. So let me just quickly drive through some of the products that we built today. Apologize, I do not know why this is so slow now. Okay, so we do a lot of things to integrate IoT devices, systems, and data platforms, and so on. This allows us to have much more direct interaction with the devices, and not only does it bring data back to us, but also allows us to control some of these things that are out there on the field. So this is a list, not necessarily an exhaustive list. So you think things like centralized cooling. We don't have centralized heating in Singapore. It's hot enough, so we don't really need that. Energy storage systems, micro auto gasification systems. Smart metering features very big. EV charging, for example, is one of the new things that we're embarking on as well. Centralized to a lot of these is what we call the Spark platform. Spark stands for the SP Universal Gateway. Basically, it's a piece of IoT gateway hardware. It's customized. We actually built the hardware ourselves. I have a small team that experiments with different hardware, and we came out with a particular gateway that we have deployed to the field. We also customize our own operating system that will allow us to do device management and has cloud connectivity. We have a cloud platform, and then we also have an app repository where developers can develop apps and then push them down to the devices. We deploy these Sparks obviously around the country in Singapore. We have been active about 2.5 years now. When some of the devices that we control are here. Actually, we do more now, but this was a bit of an old slide. Some of our deployments here, some of the larger deployments that we have here on rooftops, in substations, and power stations, controlling PV inverters, power systems, and so on and so forth. And these are the Sparks that are actually being deployed on the field. Some of the partners that we work with in terms of the devices and so on. So that's the platform. And what use is this platform? So just really quickly talking about some of these things. First is on energy sustainability for commercial buildings. So a list of many things that we do, including smart meters and infrastructure. We focus a lot of energy and operational efficiency to help facility managers to manage buildings more efficiently in terms of their energy usage. Do a lot of reporting as well in terms of analytics to be able to predict when certain devices are going down, but also be able to identify the hotspots where energy use is particularly high. Maybe that's the reason that could be because of defective devices, defective equipment. Identify this and reduce the energy consumption by rectifying the use of this the equipment itself, right? And finally, consumer focuses very big as well in terms of our products to these customers. So our occupant experience for say offices and so on. For malls, it would be like for the store owners and so on and so forth. Some screenshots of how we manage the tenant spaces. This is the app for that, and then we have a dashboard for the facility managers. For the common areas, we have showcases for building visitors, and also managing common areas again for facility managers. Some of our customers include the Changi Airport Terminal 3. So Changi Airport, if you ever visit Singapore, basically Changi Airport is our national airport, our only airport. Terminal 3 today is the largest terminal in Changi Airport. We have a total of 4 terminals. But obviously with this pandemic situation, a lot of things are a lot quieter now. But we have basically sold this system to them last year, successfully deployed so much that they wanted to cover the rest of the other terminals. And some of the other successful customer deployments as well, including office building is HDB Connection 1. Nanyang Technological University is a campus. We deployed a pretty large deployment there. And Sandcrawler building, it is that Sandcrawler. It's the Star Wars Sandcrawler. This is actually the Star Wars building, owned by Lucasfilm. Okay. Okay. Some technical difficulties again. To the next slide. Okay, a bit too fast. Okay, right. So the second part of it that I want to talk about is on distributed energy resources. We also use this platform for DERs, and that includes things like solar panels and energy storage systems. Very quickly, the screenshots of how we manage the DERs, the PVs, as well as the photovoltaic solar panels, as well as the energy storage systems. And some of our customers include warehouses, community clubs, and this is our own headquarters in SP Group. Sembcorp Marine is a large shipyard in Singapore. We actually have the largest solar deployment in Singapore, or rather, they have the largest solar deployment in Singapore on top of a single building, and we help to manage that. Tengah Smart Town is a up-and-coming smart town that we provide energy management services for them. SIT is another university that's upcoming in 2 years' time. Okay, so that's a little bit background on what it is. So let me talk a little bit about how it actually works. Okay, so let me start off with an overview of the Spark platform. At the heart of the Spark platform is what we call the Spark Cloud. The Spark Cloud is a central component that binds all other components together. It serves a few functions. So the first is really to manage and monitor the Spark fleet. So if you look here, we have this Sparks, right? We register the Sparks on the Spark Cloud. When they're turned on, you authenticate, and then you will be able to manage them. The status will show online on the Spark Cloud. We can monitor the vitals, such as things like the uptime, the temperature and humidity. We can also send it commands to do various things like rebooting, have a secure channel for administrators and so on. Then we can do things like managing the H app lifecycle. So the H apps are here. The H apps are what we call the applications that are deployed on the Spark. We register them on the Spark Cloud, and then we can install and update this H apps on the Spark through the cloud. And then finally, we have what we call the hub apps. The hub apps are basically apps that are on the cloud that have access to communicate with the edge apps running on the Spark through the Spark Cloud. And again, we register these hub apps on the Spark Cloud and set the necessary access control, which the hub apps can then use to communicate with the edge apps itself. Okay, let me go on to the next slide. It's a bit slow. Apologies again for that. So the next slide shows a edge app deployment. This is the process for deploying the edge apps on the Spark. An agent actually runs on each Spark. On startup, the agent connects to the Spark Cloud. It listens to the commands from the cloud, and then when the installation command is sent to the agent will download the edge app from the cloud together with necessary configurations and security. Then you will load and run the edge app on the Spark. Let me talk a bit about the edge to hub communication. Remember, the hub is basically the cloud-based application, and the edge is basically the application running on the device, the IoT device, which we call Spark. The other main responsibility for the Spark Cloud is to route messages between the edge and the hub apps. The routing of the message is based on PubSub, and both the edge apps and the hub apps publish and listen to topics. So the Spark Cloud have access control on both message routing to make sure that everything is secured. The hub app can only exchange messages with the Spark apps, the edge apps that they are allowed to communicate with. Okay, so that's the communications part of it, which is secure. What are the different types of edge apps we have? So essentially, we have the three types, right? So the three types are actually quite straightforward. They are the data collection, remote control, and local intelligence. So what is exactly is an edge app? It's just a normal application. We package it into a Docker container. In reality, it can be written in any language, but we actually use Go in most of our edge apps. We only have one, which is Java-based, and that's a bit of a long story. But the reason why we use Go is primarily, one of the bigger reasons is because of the smaller app size that it compiles to. And we don't need to package an environment in it, although I think that's a big benefit of using Docker. But nonetheless, the idea of running this app that's really, this container that's really small, which we can typically package to about 10 meg, versus something written in Java, which we have another app, it's about 80 meg. That actually provides a big difference, because don't forget, these are actually edge apps that deploy through the cloud to the device itself. Okay, let me just talk through the three types of edge apps. The first is data collection. This is most of our edge app use cases today, and it's quite obvious. It's quite straightforward. We use this to collect the data from the different sources. And this results in thousands of data points that is sent to the Spark Cloud every minute. And we enable a number of different protocols. I think the lists are shown here. Modbus and is something that's very commonly used with inverters and meters and so on. BACnet is very commonly used with building management systems. The OPC UA is commonly used with SCADA systems. And the EMON is our own proprietary protocol, which we use to communicate with our own energy monitoring devices. So I won't really go through all of these. I think it's a bit lengthy. Let me just skip to the next slide. So the data publishing, okay, let me just make sure we can go to, okay. The data publishing runs in a different loop, and this is decoupled from the data collection. We use persistent queues for this. So the data publishing takes in the configuration file, and then it writes. It knows where to write and publish data to, and which protocol to use. Okay, so that's basically the data publishing loop. And let me talk about the remote control then. The remote control is another use case. It's less frequently used, but This is also there are a few use cases on this, not as many as the ones in data collection. Essentially, what we want to do is to send commands from the hub app to the cloud, and the cloud to the edge app in the Spark. Right. So a very typical use is, say, for example, if you want to tell the PV system to curtail its energy output. Right. So let's say there's just too much sun and there's just too much output of electricity to the grid, and the grid can't take it anymore. So you want to curtail the energy output. This could be one of the actions. Or you could say, no, you want to cut down or you want to start discharging energy from your energy storage system, for example. So that's an example of remote control. So on the startup, the Edge app will subscribe to the command topic and start listening to commands. When the command is being received, then the action will be carried out, and this action can take some time to complete, and Edge app can send intermediate results and statuses before the final result or status when the action actually completes. Okay, so data collection is generally easier. The remote control can be a bit harder. So sometimes we have problems, especially when we need to integrate from two different protocols or two different vendors. So there is normally a little bit more difficult. The last use case we have is on local intelligence. So the local intelligence is something that's used when you are totally cut off from the connectivity, right? So one of the more commonly used, or rather one of the common use cases within within a particular system called a microgrid is on islanding. So when power gets cut, the national grid goes down, or there's something wrong with the supply, that's when you have microgrids that will kick in and to be able to support a local area, district, or whichever that is. In those cases, then you want to be able to island the not only the power supply but also the network connectivity and the control of the devices. You will want to have local intelligence. So the edge devices can actually do a lot of this processing itself, and it will make the decisions and send the commands locally without having sent back to the cloud. Say, for example, if because of this outage, then your cloud is out as well, right? So can it still continue running? The answer is yes, using local intelligence. Okay. Finally, although I talked about 3 different use cases, actually one of the very often we have to actually combine all 3 together, and sometimes it could be something that's a lot more advanced. Sometimes it could be just that you want this to be able to run things on its own and be able to do a lot of these things before sending back to the cloud. The Spark resources are limited. Generally, these edge devices are not high powered in terms of CPU or memory, but it is actually very close to the actual devices, the actual assets. So having that advantage is actually pretty good. Okay, that's it for the sort of a theory part of what we do with the platform. Let's get into the code itself. If I could just go on to the next slide. Okay, so let me talk really quickly about a simple edge app itself. So we're going to talk about building a Modbus client and connecting it to a Modbus server. This example is a PV inverter. So Modbus, some of you might know, some of you might not know, but it's a popular protocol for communicating with industrial devices. Then this will include things like PV inverters. It allows devices to communicate through TCP as well as through serial connections. In our example, we are going to use a Modbus library to connect to the Modbus server over TCP. Then we will pass in the IP address, port number, and slave ID as the connection parameters. In an actual production level kind of code, we will need to do a lot of more error handling things like connection failure that we need to do exponential backoff and stuff like that. But for example, for this particular presentation, I just make it a lot more simpler, right? So you see the example here. So how do we build the Spark Cloud client? We need to have a client for publishing to a Spark Cloud. The Spark Cloud exposes the services using the gRPC interface. So we take in a protobuf file that defines the Spark Cloud gRPC interface, and we would generate a client stub in Go. Then we pass in the Spark Cloud server IP address, port number, and TLS credentials. Then again, in actual production code, we need to do a lot more error handling, but here we just leave it be. Okay, let's go on to the next slide. Anytime now. Yes. So after these two things, we need to initialize the persistent queue and ticker. This persistent queue will decouple data collection loop from the data publishing loop. We initialize a ticker that will predictably trigger the data collection. Right. Here's the actual data collection loop running in a Go routine. We range across the ticker channel. Sorry. In each tick, we use a Modbus client to read the value from the Modbus server. An example, we are reading the value of the input register at the address 30,001 with the size of one register. If the read fails, we just end this iteration with our next tick. Again, you know, if in production code, we would do exponential backoff. Okay, this is publishing data to the Spark Cloud. Basically, the data publishing loop, it runs in another Go routine. We will range from the data channel of the persistent queue. For each piece of data that we receive from the data channel, we prepare a publish request, put the data as a message, and then assign a topic to publish the data to. Then we use the stub to send the publish request with timeout. And after a reasonable number of retries, and it still fails, we just exit, right, which cause the app to terminate. Then after that, we need to get the Spark agent to restart the app. Right, this is in a failure case. If the publishing is successful, we will send a positive acknowledgement to the persistent queue, and then we remove the published data from the persistent queue. Then we move on to the next iteration. Finally, excuse me. Okay, finally, we let both Go routines run and wait for the termination signal. And then that's it, right? So this is a really simple H app. In fact, this is actually the H app we use for a lot of cases. Of course, like I said, we do a lot more error handling with the production code. And essentially, this is the H app for Spark. It's really simple. We actually try to open this up to other developers as well to start developing on it. The ultimate idea that we have is really to enable a sort of like an ecosystem that people can start deploying things on it. We have made some advancements in that. We have started collaborating with a couple of universities. Well, there are not that many in Singapore. With a couple of universities and also some organizations to start doing that within our own ecosystem. We have not brought the Spark platform outside of Singapore. Today is still primarily in Singapore, but I think that's something that we plan to do sometime near in the future. Okay, so I think that's the end of my presentation. First time I've done a presentation like this online. I hope everything went well. I see a lot of questions now. I don't know what I should do next.
Yes. So I will read you the questions now, but actually I wanted to say first that it was a wonderful talk. It was super interesting. And thank you so much for your time. And I will read you the questions without further ado because we have quite some questions. The first question is, assuming a highly regulated environment where a custom Linux is needed, were there any challenges in using Go?
Yeah, so we are talking about regulated environment, meaning the regulated by the government. If that's the case, then we actually run through the so within the SP group, where SP Digital is a subsidiary organization, we actually have a separate security group that will review all our code, and so our kernel and everything that we do. So they run through it. The government do not do anything like that, right? And we don't need. There are no laws to particularly to govern it, but there are national security rules that we need to follow, security by design and so on and so forth. So we actually follow that as well. Challenges in using Go? No, I think generally speaking, it's relatively. I mean, we have not been challenged so far, right? And we have not faced any difficulties with using Go.
Okay, thank you. And there's another question: is Spark Cloud your own cloud platform, or are you something using? Or are you using something like AWS?
Yeah, we are not using AWS. We're using Azure from Microsoft. So we host a lot of things on Azure. We actually have two Spark platforms, two instances. The first instance on the cloud, right? That is primarily for external customers. And then we have a Spark instance in-house as well. So that's on-premise within our offices for SP Group. Because, utilities, you need to deploy internally. So there's a firewall and everything that you can't actually get out. So we have two instances. For the external one on the cloud, we use Azure. That's because we have a ongoing relationship with Microsoft, and they give us good rates. It doesn't really need Azure, but and we go for whichever gives us the better value.
There's another question. What features of Go led you to picking Go as a language for this project?
I think so. I mean, the reason why we picked Go for this particular thing is primarily me, actually, because I am one of the initial Go proponents in Singapore, and the team that I built basically a team of Go developers, and we think that this is a good language to use for this particular use case, and we embarked on it, right? So could this have been developed in any other programming languages? I think probably yes, and I've seen some others using other languages as well, but I believe Go has its advantages, and one of the advantages I mentioned earlier on is the small size in terms of the footprint of the Docker containers that we deploy, and that everything is pretty much self-contained within the container. It's a lot easier to deploy. So that actually counts for quite a bit. Is that a huge advantage? I wouldn't say that none of the others can overcome it, but it's a language that we're comfortable in, that we enjoy writing the software in, and it works really well for us. So that's why we ended up using it.
Yeah, in edge computing is super important to keep like a small size. I remember having these troubles.
Yeah. Of course, we have other people ask us as well, why not write in C, right? So that's a valid thing to do as well. Except that I have a lot fewer C programmers, available for me to choose. Yeah. So Go is a good compromise. Yeah.
Yeah, and the trade-off is actually not that bad. Yep. So do you also use Go for the data analytics?
No, we use Python.
Yeah.
Like everybody.
And how are you receiving the messages when you do the publishing? Do you use Kafka or something similar?
Yeah, we do use Kafka. Yeah, we do use Kafka. I mean, there's quite a bit of other technologies behind the scene, which I didn't actually run through. because primarily because I probably talked too much initially about why this is for, and they really didn't leave too much time later on. Yeah.
I actually could actually found the background very interesting, because otherwise maybe we wouldn't have been able to actually understand what was going on, or why this was like so important.
Yes.
And the last question we have is local intelligence some kind of machine learning thing? Is it in Go?
So the local intelligence here is it could be machine learning, but in the case of machine learning, we'll probably not use Go, because again, primarily because my guys who are good in machine learning are more proficient in Python, right? So we would deploy on that. But the ones that we have deployed are in Go. They are not machine learning. It's basically a simple control loop, right? So if this happens, you package it this way, you process it and chop it up that way, and then you send it to the other device. So a very typical one is I receive some indication from one particular device, and that will trigger activation of another device. Say, if let's say the output for the solar has reduced over time for a particular period, what will kick in? It will start discharging from the energy storage, right? So that's the kind of local intelligence that I'm talking about. So it's more of a control loop rather than actual machine learning artificial intelligence. But it is intelligence because you do not need to bring all the logic back to the cloud, right? And if I chop off the cloud, if there's no connectivity to the cloud, then it can actually perform all these actions on the edge.
Yeah, since you cannot really ensure that there will always be connectivity on site, it's actually a very
that's right. Because
very valid.
Yeah, because one of the things that we do this for is for microgrids, and microgrids we are talking about islanding. You do not just island the electricity and then you just neglect the data part of it, right? You cannot just assume the cloud will always be there. So you need to island the data connectivity as well. And to do that, we need to have edge devices to be able to control the intelligence. That's what the reason why we have this particular kind of technology.
Okay, we have run out of time, and hoping will cut us off at any minute. So thank you so much for everything, and yeah, tune in like 5 minutes, I think.
Thank you.
Thank you.